All right, so more maximizing and minimizing equations. I gave optimization problems before where you had two equations. Sometimes you get all the information that you can put together into one equation immediately. All right, here we go. So we've got a piece of cardboard that is 24 by 24 by inches. So we've got a square piece of cardboard. All right. So what we're going to do is we're going to cut out the corners and fold them up to be a box. So if I cut out these corners and fold them up, I know you've seen this kind of a problem before. So just think of it as like the box top of a printer box of paper. So we're going to have this kind of thing, right? Bad drawing, but that kind of a thing. Okay, and I'm going to want to find the volume of it. How much will that hold? All right, I'm cutting out squares. So I know that this whole distance is 24 inches, right, from here to here. And I'm going to be cutting out these little squares. So each square has width X, right, that I'm cutting out here and here. So those are the squares that I'm cutting out. So if I'm going to find the volume of this box, let me draw it again down here. I'm going to have this side with this height X, right? And this side with this height X. So what are the lengths of these sides going to be? The length of each side will be 24 minus 2 x's, right? If all of this length is 24, I'm going to take away this x and this x. So what's left here is 24 minus 2x. Okay, so volume is length times width, which will be another 24 minus 2x, times height, which is x. That's the volume of the box. That's what I want to maximize. So this is going to be what I want to take the derivative of and set it equal to 0. We could do product rule. We could multiply it out. Let's just, well, I'm going to just multiply it out. So volume is 24 squared minus, so 2 times 48x plus 4x squared times another x. So I get the volume is 24 squared minus 96x squared, whoops, 24 squared x, I'm sorry, I lost the x there, and then plus 4x cubed. Okay, this is what I'm taking the derivative of and setting it equal to 0. So the derivative will be 24 squared minus 96 times 2x plus 12x squared. So I'm going to be setting that equal to 0 and solving. Okay, so let's fix this here. So I get 576 minus 192x plus 12x squared equals 0. So if I divide through by 12, I get 48 minus 16x plus x squared equals 0. So let me just write it like this so I can think about it. I think this can factor to x minus 12 times x minus 4 equaling 0. So that gives me x equal 12 and x equal 4. Okay, so don't usually get two answers. So let's think about each of those answers. So if I fold up x equal 12, if I use the distance of 12 to fold up, wait a minute, the whole thing is 24 inches long, there would be no box. So that answer gets eliminated. So the width of the square that I'm cutting out is x equal 4, and then the dimensions, so that would be the height. So height of the box would be 4, and the width and the length would be the same thing, and that would be 24 minus 2 times 4, 8, right? So the width and the length would be 16.